Okay, this is another part about the parallel circuits imposing a problem when measuring components within the parallel branches, like this or this. Now, of course, you have 120 volts coming from the source. You put one probe there and one probe down here. Of course, it's going to measure 120 volts. But that's not what the case is. The voltage going through here, and the voltage is going through here. Okay? And I proved that in the last video I made regarding that. Now, we're going to look at some of my figures here. And we're using this time 200 watt light bulbs in parallel. Now, for 100 watt light bulb, the power equals I times E. So the power is 100 and the voltage is 120. So 100 divided by 120 is 0.833 amps. It's the current. Now, I talked about that last video. Now we're going to look at 200 watt light bulbs in parallel. And this is how you find total resistance. Take the reciprocal of R1 plus the reciprocal of R2, which equals 1 divided by 144.1 plus 1 divided by 144.1 again equals 0.007 plus 0.007 equals 0.0140 ohms. So the resistance total is 1, divided by that equals 71.43 ohms. Now, where did I get this 144 from to begin with here? Oh, okay, I missed this up here. Yeah, I talked about that, but I didn't go over here. R equals E divided by I. 120 divided by 0.833 equals 144.1 ohms. That's where I got that from. Now we go down. There's some formulas there. You use to calculate I. I rarely use that one. Now from here, I equals E divided by R is that, and that comes to 1.68 amps. Therefore, the two current of each of those equals 1.68 divided by 2, because they're dividing the current, sharing the current by 2, equals 0.84 amps. So therefore, if E equals IR, then E equals that. Oh, that's 35.715 ohms. So 30.0006 volts. That's really low voltage compared to the 120 volts at the source. Therefore, the power of R1 and R2 equals IE, which is 0.84 times that 30 volts, is 25.301 watts. And then the power of R1 in power with the power of R2 is 25.2 times 2 equals a 50.4 watts. Was that say there? Yeah, for 2 branches. Now let's go back to here. I don't think I did that. Power equals I times E. 1.68 amps times 120 is 201.6 watts. And that's what we're using is 200 watt light bulbs would equal 200 watts. Yeah, I did that. Okay. So over here, now we're using the proportion formula. 50.4 watts over 200 watts equals X over 100. That calculates to 25.2. Therefore, we should only be paying 100 minus 25.2 times 3, which equals 75.6. So 100 minus 75.6 equals 24.4%, which that's the percentage of cost, I think, yeah. Out of 100, say $100. So I wrote here, therefore, only $24.40 should be paid instead of each $100 charged by electrical companies. Okay? So I'm kind of being bold to state this and put it on YouTube for anyone to watch. Now there's a plugged in there. Now I don't know, how can they detect with their meter on the outside of your house how many devices are plugged in there? There's no way they can check the voltage drops in parallel. I don't have any of those other multiple plugs you can put in here. That's okay. You know, you can plug those three-way ones that go in here. You know, how would they know how many devices got plugged in there? There's no way they would know that. So I don't understand how they know how many devices we're running. Okay, now here, that part about 30 volts. Okay, the 30 volts is all that is needed over top of one each of the light bulbs, 200 watt light bulbs, only 30 volts. But the current is going to be the same amount of electrons, but it's only going to need 30 volts to bounce them around in there to cause enough light, instead of 120 volts AC. because there's less resistance, much less resistance in the whole circuit. It's like two extension cords. If I plugged 2 extension cords right into this lamp, the resistance of the wires would be divided in 1/2. So right there, that would save some current and electricity. So I think I've proven this, and I'm going to do more about it in the future. And I got another page there, and well, that's something different there. Yeah, I'm going to be talking about an easy way to remember a couple of formulas. Power equals current times voltage, and voltage equals current times resistance. I'll be talking about that in a short video. Okay, thank you very much for watching the Super Puts channel again. Bye.